Alright, hello viewers. We are going to consider another method of approaching ordinary differential equation, and this method is separation of variables. Okay, separation of variables. You apply separation of variables when you are able to separate x from y. What that means is you're able to take x to one side and take y to one side conveniently without having x mixed with y or y mixed with x. That is what it means to separate the variables. So whenever you see an ordinary differential equation where you are able to separate x and you are able to separate y, and that you can use the method of separation of variable. So let's go into um, the solution so that you understand what I'm talking about. Now in differentiation, when you see y prime is the same thing as dy dx. When you see y prime prime is the same thing as the square y over the x squared. So we are going to bring that value into this. So whenever you see y prime is the same thing as the y dx. So let's take solution. So we know that y prime is the same thing as dy dx. So we are going to substitute it into this, and then we write out the equation. And again, note we've been given boundary condition or initial condition, and we have y into 1 equal to 5. What this implies is that the value of y is 5 and the value of x is 1, because this is how it is. This is the same thing as saying y into x equal to 5. So x, this value of x, you can liken this to be equal to this, so that when you see something of this nature, it means y is 5 and x is 1, because we are dealing with x and y in this equation. So that is it. So this is our boundary condition. We are going to apply it. When it is time to apply it, I'll definitely apply it. So we know that y prime is the same thing as dy dx. So we are going to bring it into this equation so that we have y. Okay, we have y prime is dy dx. Dx will be equal to 8x plus y divided by y. And now if you look at this question, you can easily or conveniently separate x from y. You can put y in this, the left hand side, and then you can put x in the right hand side. So we are going to go through that process of mathematical solution to achieve that. So first, let's move x to where we have 8x plus 1. So in order to achieve that, we can say multiply both sides of the equation by the x. So we say multiply both sides of the equation by the x. And so when you do that, we are going to have this y dy dx times dx will be equal to, because we have a lot of variables here, so this will be equal to 8x plus 1 all over y multiplied by the x. Okay, so that when we cancel out this, we are going to have y dy equal to 8x plus 1 all over y multiplied by the x. So we've been able to move the x to where 8x plus 1 is. We are trying to separate the variables so that anything that has to do with x will stand in one side, and anything that has to do with y will stand in the other side. So how do we now eliminate this y from here so that it will move to this other side? So we can say again, multiply both sides of the equation by y. So we say multiply both sides of the equation by y. So if we implement this mathematical statement, this is how it's going to be. So we have y, which is this, times y dy, which is this, equal to, we have y times into, we are going to have 8x plus 1 all over y is multiplied by dx. And so when you cancel out this, and you say y times y will be y squared, so you have y squared, there's a dy here, so we have dy equal to, you have cancel out here 1, 1. So we have 8x plus 1 divided by 1 will still be 8x plus 1. So we have 8x plus 1 in dx. So looking at this equation, you've been able to separate y. Y is now taking the left hand side of the equation, and x, dx, is taking, and everything that has to do with x is taking the right hand side of the equation. So at this point, we can now use direct integration. We've been able to separate the variables at this point, because if you look at it, we have 8x plus 1 taking the x, and in the left hand side is only y dy that we have. In the right hand side we have 8x plus 1 dx. So we've been able to separate x from y confidently and successfully. So at this point, since we've been able to do that, we can now use direct integration to solve the problem. And so I can make a mathematical statement here, integrating, or if I don't want to do that, let me use this dx to open the bracket first, so that we have y squared dy equal to, if I use this to open the bracket, I'm going to have 8x plus the x, because, okay, sorry, 8x times dx will give us 8x dx plus the x times 1 will give us the x. Okay, so we've been able to have only x, only y in the left hand side, and only x in the right hand side. So at this point, I can say I can now use direct integration to solve the problem. So I'll say integrate both sides of the equation. Okay, can we use that? Okay, let's see, can manage it. Okay, so if I integrate, the mathematical statement is to integrate both sides of the equation. So starting from the left hand side, I'll say integral of y squared dy will be equal to, this is 8x, 8 is a constant, so I'll bring it out and integrate the variable. So we have 8 integral of 8 x dx plus, we integrate integral of dx, that is this one. So if we integrate y squared dy, this will be y raised by 2 plus 1, that is the power plus 1, divided by 2 plus 1. This will be equal to 8, place it in brackets. If we are to integrate x squared dx, it will be x, because we have original 1 here, 1 plus 1, divided by 1 plus 1, plus, if we integrate dx, it will give us what? X. Plus remember, whenever you are doing integration, you add the constant of integration. Add the constant of integration, which is c. you add the constant of integration, which is c. And so when you solve this, y raised to power 2 plus 1 will be y raised to power 3, y raised to power 3, and then 2 plus 1 here will be 3, equal to, we have 8, x raised to power 1 plus 1 will be x raised to power 2, divided by 1 plus 1 here will be 2, plus we have x, which is this one, plus our constant of integration. Again, we can cancel out something here. 2 here, 1. 2 here will give us 4. So that we have our y cubed over 3 equal to, now we are going to have 4x squared plus x plus c. We are not done yet. We have to remember that we were given an initial condition here. We have to remember we were given an initial condition here. So at this point, we can now bring in our initial condition. And like I said earlier, if you have y into 1 equal to 5, and you're dealing with x and y, it implies that y is equal to 5 while x is 1. So we have to bring in the value of y, which is 5, and then the value of x, which is 1, into this equation. And so when we do that, we are going to, the value of y is 5, and we know 5 is, y is raised to power 3, so we raise it to power 3 divided by this 3, equal to, we have 4 into, the value of x is 1, but x is raised to power 2, we raise it to power 2, and then plus, x here is 1, 2, plus c. Now we are doing this because we want to know the value of the constant. We want to know the value of the constant c, so that once we find the value of the constant c, we can now take it to this original equation. This is the original equation. We can take it back and write the value, and then that will be the end of our solution. So please let's move down to this other side to complete our solution. So 5 raised to power 3 from this point, 5 raised to power 3 from this point would be 125, and it's divided by 3, equal to, so 4 times 1 raised to power 2 is still 4, plus this one, we have plus 1, plus c. And so this is equal to 125 divided by 3, equal to 4 plus 1 is 5, plus c. And so because we are looking for the value of c, we have to move 5 to this other side so c can stand alone. So we are going to be having 125 divided by 3 minus 5. And so we can find the reciprocal and equate it to c. And so at this point we find the LCM. So the LCM of 3 and 1 will be 3. So we have it to be 3 here. Roll it. 3 into 3 is 1, multiplied by 125, that will give us 125. Here is minus, so we write minus. And then 1 into 3 is 3. 3 times 5 here will give us 15. And so we equate it to c. Please let's continue our solution here. And so 125 minus 15 will give us 110, and it's divided by 3, equal to c. So what this implies is that c is equal to 110 all over 3. That's the value of c. And so we can now bring in that value here. We now bring in that value into this equation. So bringing the value of c into this equation, we have, okay, let's call this equation 1. Okay, let's call it equation 1. Let me do it properly. Equation 1. So bringing the value of c, let me make the mathematical statement. So I'll say bring in Okay, put in the value of c into equation 1. This is equation 1, we call this our equation 1. So if we bring in the value of c into equation 1, we are going to have, this is equation 1, y cubed over 3 equal to 4x squared plus x plus the value of our c is 110 divided by 3. And so because we are not looking for y cubed over 3, we are looking for the value of y. And so we can say multiply both sides of the equation so that we can eliminate this 3 so that we can have y cubed to stand alone. So we can say multiply both sides of the equation by 3. So I say multiply both sides of the equation by 3. Okay? Multiply both sides of the equation by 3. So if I multiply this equation, both sides of this equation by 3, from the left hand side, I'm going to have 3 times y cubed all over 3. This is the 3 I'm multiplying by this, will be equal to, because we have a lot of variables here, so let's multiply it bit by bit. This will be 3 times 4x squared plus, we are done with this, so this will be 3 times x plus, this will be 3 times 110 divided by 3. So we've been able to multiply both sides of the equation independently by 3. So we can cancel out this so that we have that y cubed will be equal to 3 times 4x squared will give us 12x squared plus 3 times x will give us 3x plus, of course we can cancel out this. This will be 1, this will be 1. So 1 times 110 will be 110. And so we now have, this is y cubed. Okay, let me do it this way. Y cubed equal to. So we now have that our y cubed equal to 12x squared plus 3x squared. 12x squared plus 3x plus 110. You can decide to keep your answer here, or you can decide to solve further by making this mathematical statement. You can decide to solve further by making this mathematical statement, because we want to have just the value of y. So you can say, since this is a cube, since y is raised to power 3, in order to eliminate the 3 here, you say find the cube roots of both sides of the equation. So when you do that, when you implement this mathematical statement, you are going to have cube root of, let me write it properly, cube root of y cube will be equal to the cube root of the whole of this expression. We have cube root of 12x squared plus 3x plus 110. So because this is cube, this can cancel out, and so our y will be equal to cube root of 12x squared plus 3x plus 110. Okay, that is the value of our y. And alternatively, you can also write that our y is equal to 12x squared plus 3x plus 110, all raised to the power of 1 over 3, because cube roots can also be expressed in this form. Cube roots can also be expressed in this form. So basically, this is how to solve question when you are asked to separate variable. Remember I said in separation of variable, you have to ensure that you can separate x conveniently to stand alone, and you can also separate y conveniently to stand alone. But if you have a situation whereby you cannot do that, you try to do that mathematically and you cannot achieve that, it means you cannot solve that ordinary differential equation by method of separation of variable. So watch out for my next video on another method of solving ordinary differential equation. Thank you.